So I talked about trusses last time. So trusses have triangular configuration. So we'll discuss some problems dealing with trusses. So you can take an example of a typical truss. So this is your example of a typical truss. It's a triangular configuration. And you apply the load at the nodes, at these joints. So members or bars are connected with pin joints. Other thing is, assume all loads are applied at the pins. So these are the assumptions for solving a truss. Solving a truss means finding internal forces in the bars. So you have got bar A, B, C. So this is a hinge support. This is a roller support. So roller support means movement is allowed in the tangential direction, but no movement is allowed in the perpendicular directions. In this direction, you are not allowing the movement. Only movement is of the roller or pin is allowed in the tangential direction. Here, both x and y displacements are constrained. So you can take x direction, y direction. These are z direction. So your truss is in xy plane. And your load is also in xy plane. Load is P. Now assume that all bars have length 1 meter. So you come to know the angle. Each angle is 60 degrees. Now we have to solve this truss. So there are two ways to do it. First, we can find the reactions. Step 1. This is what is usually done. Find the reactions. What do you mean by reactions? Force caused by external support. Now it is supported at point A and C. So you have to find the forces caused by these external supports. Now these two bars, all these bars are connected with a pin joint. So basically a rotation is allowed. between the two bars. Only constraint is displacement in x and y direction at each pin has to be same, whether you're on bar AB or BC. Similarly, whether you're on bar AB and AC, displacement of point A is same. But this angle can slightly change. It is not a welded joint. Basically, that means you cannot have a movement here. There cannot be any movement, restraining movement applied by bar AB on bar BC. Only force allowed is force components in x and y directions. So first we find the reactions. So you draw a free body diagram. I represent, write FBD for free body diagram for the structure. The free body means remove the support. Support is gone. But instead of the support, the effect of support is there. So this was point A, B, and C. My coordinate system. And the force in x direction is AX. Force in y direction is AY. Here there is a force only in y direction, CY. And you have the external force P. So, what are the equations of equilibrium? This is a plane truss, meaning that the all members are in plane XY, forces are also in plane XY. So you have got only three equations of equilibrium. Now you take first equation. So what is the force in x direction? There is only one force in x direction, that is AX. So it has to be 0. What are the forces in y direction? AY plus CY, and there is a force at point B, external force. So you see this force is acting in downward direction. So you write minus B. So this is your force balance in y direction. Now you have to say mz is 0. So whenever you find movement of forces, you have to say about what is the reference point. So you say movement, you take the reference point as point A. So you have to find, now this each distance is 1 meter. So this distance is 60 degrees. So what is this distance? Distance AD is,
So root 3 by 2.
okay. So we can say it is cos 1 into cos 60, the root 3 by 2. So movement about point A will be because of forces, reaction forces at point A will not cause any movement because they are passing through point A. So the radial arm is 0. So movement is 0 by forces AX and AY. Now force B will cause a movement. Now you find the perpendicular distance to the line of action of force at B. So that is distance AD, and the length is root 3 by 2. And this force is P. Now you have to see what kind of twist it will cause around about point A. It could be
सर cos
a
60
twist.
1/2 होता है.
Yeah. Okay.
Cos
Sorry. 1 by 2. You are right. So this is only half.
AD तो 1 sin 60 है ना?
AD is cos 60.
Oh,
There is an angle at the base. Okay. Now half P, but you see this is causing a clockwise twist. This is going to cause a clockwise twist about point A. So movement has to be negative. And similarly, at point C, this Cy is vertically upwards. So it is going to give it a counterclockwise twist about point A. So you will get plus, the distance is 1. So 1 into Cy. And the entire thing is a movement about Z axis. You need not write K because you have written MZ. So it is obvious that this is movement about Z axis. K is not needed. So this has to be 0 because net movement due to all forces has to be 0 for equilibrium. So you can get Cy is equal to P by 2. Now you look at this equation, Ay plus P by 2 minus P is equal to 0 implies Ay is equal to P by 2. So you know your Ay and Cy. Also by symmetry, you see this entire structure is symmetrical and force P is vertically downwards. So by symmetry also you could have said Ay and Cy are equal to P by 2. So we have done it full-fledged. Any questions? So it is very important to know how to calculate reactions. And this is the only way. You use equations of equilibrium, force balance in x direction, force balance in y direction, moment balance. Any doubts? Now what is there is that we have to solve the truss. So we are assume all bars are in tension. Suppose some bar is in compression, then what will happen? The internal force sign will be negative. If the internal force sign is positive, then it stays in tension. Otherwise, you come to know it is in compression. Now I'll explain it. So you pick individual bar. So these are your individual bars. You have to draw their free body diagrams. You see, so they are connected to a pin here. So what are the forces on these bars? Since only forces are at 2 points, so this is a two-force system. How can a two-force system be in equilibrium? If the forces are coaxial and equal and opposite. Any doubt about this?
no,
This
sir.
is very fundamental. Otherwise, you will be in trouble. So you can say there are forces on these bars, and you assume these bars are in tension. The forces have to be like this for it to be in tension. So I have shown the internal forces in the bars. So I'll call force this force as TAC, TAC. Similarly, this force will be TAB, TAB, TBC, TBC. So this is the nomenclature you use. Any questions? Now you take this pin. this pin at position A. So what are the forces coming onto the pin? Number one is the external force, P. This force TAB. So that will be like this. Similarly, force TBC. So you have to draw forces equal and opposite to these forces. By Newton's third law, if pin is pulling it in this direction, here pin is pulling it in this direction. Force is coming from the pin. So point B, bar AB will pull the pin in opposite direction. So it is pulling it in opposite direction. Any doubts? Like here, pin C. So this force TAC will be like this, and force TBC will be like this. Bar BC is having tension TBC. Pin is pulling it in this direction. So bar will pull pin in the opposite direction. Similarly, point A, if I draw it here, there is a force TAC, TAB. Then there are forces from the support. So this is a pin A. Any doubts? Any questions? If somebody has a question, ask. Whether the bars are in compression or tension, you assume they are all in tension. It makes your life easy. Otherwise, you keep thinking whether it is in tension or compression. Then, since the bars are in tension, so the pins will have forces always like this. Always like this. So their forces will be in the opposite direction. Now you have to apply equation of equilibrium to the pins.
सो जैसे हमने ए पॉइंट पे ए एक्स ए वाई लिया है, उसी तरह हमें सी पॉइंट पे भी सी वाई लेना चाहिए था.
You are right. So there is a CY. So this is known as method of joints. So we have to apply external force CY on pin C. Okay. So there are internal forces as well as external forces on the pin. Internal and external. All right. So now we have to take joints, which now you see it's a method of joints. So you have to, how many equations of equilibrium a joint has? Yes. How many equations of equilibrium are there for this joint?
सर एक एक्स एक्सिस के लिए होगा, एक वाई एक्सिस के लिए होगा.
Only two. You won't consider movement of forces because all the forces are acting on a point. So movement, if you take about point A, it is zero. So it is not giving you any new equation. It will just give you 0 is equal to 0. So you take only two equations of equilibrium for a point. Like just for a particle, how many equations of equilibrium are there? Sigma fx is 0, sigma fy is equal to 0, sigma fz is equal to 0. We don't talk of any movements. Simple force balance. Okay. All those movements of equilibrium exist for, so movement equilibrium you do for extended objects, not for point object. So you have these two equations of equilibrium. So you choose a joint which has only two unknowns. Otherwise, you can't solve it. So we will take a joint which has got two unknowns. Now here all the joints have only two unknowns. Suppose you take joint A. Sorry, I have mixed the joints, I think. So this is joint B. So joint B I take. Force P. TAB, TBC. Now you know internal angle is 60 degrees. Okay. So what are these angles then? Here also 60, 60. So this is a symmetric structure. This angle is a 30, 30. If you draw a perpendicular. Now these angles are 60 each. Now we do sigma fx is 0. What is sigma fx? TBC into cos 60. And what is contribution of TAB? TAB cos 60. Now you see the sign is component will be in the negative x direction. So you put a minus sign. So this sum should be 0 because force P is vertical. It will not cause any x component. So this implies TBC is equal to TAB. Cos 60 will knock out. Now sigma Fy. So there is a vertical force minus P. Now TBC component, vertical component is TBC sin 60. Similarly, TAB vertical component is TAB sin 60. Both are downwards. You see the direction is downwards, so there is a minus sign. So this has to be equal to 0. Any doubts?
No, sir. सर ये बाय वाले में टी बी सी साइन 60 होगा ना?
Yes.
सर ये बाय वाली जो इक्वेशन है इसमें माइनस टी बी सी साइन 60 होना चाहिए.
Where? Sigma fx.
सिग्मा एफ वाई उसमें सर माइनस पी देन माइनस टी बी सी है ये आई थिंक.
Sorry, TBC. Okay. Now is it all right?
यस सर फाइन.
Now you know TAB and TBC are same. So you can say implies TBC. What is sin 60? Root 3 by 2. So you have to do twice because it is adding up. Is equal to minus P. Is it all right? Implies TBC is equal to minus P by root 3. So you get the internal force in bar BC. The force in bar AB So TAB will be equal to TBC equal to minus P by root 3. So you see your bar ABC so these two bars you had assumed in tension, but this sign is negative. So basically they are in compression. You come to know that they are in compression because of this negative sign. All right. Any doubts? Now we go to point A, or we can take point C, whatever. Joint A. What are your forces? TAB, TAC, AXAY. Now TAB you already calculated is minus P by root 3. TAC you have to find out. AX and AY are already known. AY you found was P by 2. AX was equal to 0. So what is your sigma fx? AX is 0. AY doesn't have a AY is a vertical force. So you got AC. AC is horizontal force because bar AC is horizontal. So you directly get TAC. It is acting in positive x direction. Then TAB has a component in x direction. So TAB cos 60. So it is pointing in positive x direction, so plus. So these are all the forces in x direction. So this sum has to be 0. So implies TAC is equal to minus TAB cos 60. TAB is what? We already calculated minus P by root 3. So minus of minus P by root 3. Cos 60 is half. So this is your force in bar AC, internal force in bar AC. You see it is positive. So this bar is in tension. The two bars are in compression, one is in tension. Any questions? So now you have solved the truss. Finding internal forces in the members is called solving the truss. So you can find also stresses. Stress is force upon cross-sectional area, the area of cross-section. So when the internal force is positive, you call it a tensile stress. When the internal force is negative, you call it a compressive stress. Any doubts?
No, sir, clear.
So this was the problem we solved. We know the stresses. So let's write down the forces which are there. TAC is P by 2 root 3. And what was TAB? P by root 3. So we know the stresses. So uniaxial stresses are there in these bars. So, suppose this is the bar, the force is like this. So you have a compressive stress. This is the bar AC. Your stress forces are like this, tensile stress. So this bar will stretch. this bar will get reduced in size, reduced in length. It will contract. This bar will also contract. So can you find the change in length of the bars? Because you know the stresses. You have read Hooke's law in your 12th standard. Have you read Hooke's law? Yes. Have you seen this expression? Anybody? Lavish?
सर थोड़ा मतलब धुंधला धुंधली सी यादें सी हैं.
So just stress and strain, there is a relationship, a linear relationship. If this is a stress, this is a strain. This is the way your relation is. This ratio is called E. So this is delta sigma, this is delta epsilon. So this slope is E. So strains are of very small value. So you may have something like 0.1% strain, meaning 0.001. And stresses are larger. What is your Young's modulus value for steel? 200 gigapascal. Suppose you have got a strain of this value. So what is your stress? What is the delta sigma? So basically, the total strain will be this. This value is 0.001. So what will be this sigma? Since it is a straight line, delta sigma by delta epsilon is equal to your whatever is the final sigma upon epsilon. Final epsilon is 0.001. This is a stress. So this is 200 gigapascal. So what is the value of stress? So you get a value of 200 megapascal. So this is the strain at elastic limit. You might not have heard of elastic limit. Have you heard of elastic limit?
सर इलास्टिक लिमिट वो लिमिट होती है जिसके बाद वो पार्टिकल ब्रेक हो जाता है.
ब्रेक नहीं होता, it undergoes.
सर मतलब वो अपना डिफॉर्मेशन होना शुरू हो जाता है, बट अब वो सेम शेप में नहीं आएगा. अब उसको तो डिफॉर्म हो गया तो
Deformation does not go back. As long as deformation goes back, if you release the load, it goes back to its original shape and size. Then you say it is elastic deformation. But suppose deformation does not go back, it is called plastic deformation. So this is the strain at elastic limit for steel. So you see, this is a very small strain. Suppose you have a bar of length 1 meter. So what is the strain? Delta L by L. So this is 0.001 at elastic limit. After this, material will not be elastic. So what is the delta L? 0.001 meter, if this is 1 meter. So your change in length is 1 millimeter. You see, 1 meter bar changes only by 1 millimeter elastically. If you try to apply more load, then it will not go back. It will contract this 1 millimeter because whatever that happened was elastically. But after that, whatever deformation will occur, that will occur plastically. That part of the deformation will not go back. Any doubts? You also have a class, lab class, and I shared one video on universal testing machine. All of you have seen that. You also look at videos
सर
on
वो
hardness
क्लासरूम
test.
पे सर जो आपने लास्ट टाइम जो भेजी थी सर वो वीडियोस शो ही नहीं हो रही सर. वो दिखा रहा है कि नो क्लास फाउंड.
What you do, you just Google universal testing machine, and you will be able to see a lot of videos. Okay, you say YouTube video universal testing machine, and you will see a lot of videos. You look at them. Okay,
ओके सर.
They tell you how to draw a stress strain diagram. They will tell you that this is the way stress strain diagram looks like for steel. This is a fracture point or failure point. This is the maximum stress. This is the elastic limit. You see, the curve is linear, and this is a yield zone. Yielding starts. This is also yielding is occurring, but there is strain hardening. We are doing a course in metallurgy this time, so there also you will be taught all this. And this is known as highest point or ultimate tensile strength. After that, material starts thinning. Thinning starts here. Suppose you have a sample. Sample is like this. Suppose you take a horizontal sample. You look at ASTM standards. So they make a dog bone specimen. So you'll find as after this point, it starts thinning. Okay. So the bar is thinning. And then it fails here. So there will be a rupture in this structure. And failure occurs. So this part of the graph, which is linear, this is represented by a slope E. This is known as Young's modulus. What is the strain? Sigma by E. If you know the stress and you know the Young's modulus, you can find the strain. Now in this case, what was our stress? So we were having something like this. So these were our internal forces. So what is the stress? The stress in bar AB. We call it normal stress in bar AB. So minus P by root 3, its cross-sectional area. Okay. Now suppose the force P is 1 kilonewton. So you got minus 1000 upon root 3. Suppose the cross-sectional area is 1 centimeter square. So what do you get? 10 power minus 4 meter square. So you are getting this is your stress. Any doubt?
No, sir.
So you are getting this stress. So what is the change in length? Delta L upon L is this minus 10 power 7 upon root 3 divided by Young's modulus. Young's modulus I told you is 200 gigapascal. This is a Young's modulus. Pascal is 1 Newton per meter square. So you get the change in length of bar AB. Similarly, change in length of bar BC will be same amount because stresses are same.
Yes, sir.
Same amount. So what is that change in length of the bar AC?
सर
Since these
एसी का
lengths are
मतलब होगा
1
सर
meter,
क्योंकि में प्रेशर अलग है.
so now you see it is having a factor of 2 below. So basically it will be, so this is it is in tension 10 power 7 twice of root 3 into 200 into 10 power 9. Okay. So what is this value? If you check it out,
सर एसी एबी वाले में है 2.89 into 10 power minus 5.
what? Just a second. How much it is? 2
सर
point.
2.89 into 10 power minus 5.
So this is your change in length in meters. So here it will be basically further half of that.
1.44 into 10 power minus 5.
So you get all the changes in length. Now I will tell you there is a concept of strain energy. I have not talked about it so far. So you can find strain energy of each bar. So whatever is the deformation stored in the body, so that is basically a reflection of the strain energy stored. And the expression for strain energy, I am just giving you the expression. Half sigma epsilon into the volume of the bar. Now you see how what is the stress. So instead of using that, what we can do is half. What is the stress? E epsilon. You can also write stress is E epsilon. Further there is an epsilon, so it's square into volume of the bar. What is the E? 200 gigapascal. What is the strain? You calculated 2.9 into 10 power minus 5 plus square. So this is the energy stored. Also you have to multiply it with the volume. Length is 1 meter. Area of cross section I told you is 10 power minus 4 meter square. So overall you have got answer in joules. So this energy is stored in bar AB. Similarly in bar BC also same energy. In bar AC what is the energy? Half into 200 into 10 power 9. Now your strain is your your strain value is half of that. Your stress was half, the strain is also half of that. So basically you will be whatever is the answer here to do divide by factor of 4. Because it is proportional to strain square. If your strain is half, then energy becomes 1 by 4. Can you calculate this energy? Anybody? Can you give me the answer? Okay, I will calculate it roughly 339. You get a factor of 9 here. Then minus 10, minus 14, So minus 14 is to 10 power minus 3. This is 11. So many joules. This is in 1 bar. So what is the total strain energy? Sum the energy in all the bars. So 9 plus 9. And what is the strain energy in the third bar? 9 by 4. This is the strain energy stored. So this you see is around 20 into 10 power minus 3 joules, or you can say it is 0.02 joules. Okay. Now if you look at the structure, this is the force P. Can I find the deflection of this node B? What is deflection of node B? How much it will move vertically downwards? Can you get it? Can you guess it? Look, whatever is the energy stored in the truss, that is coming from the work done by this force. What is work done by force P? Anybody? Half P into deflection of point B. So this has to be equal to 0.02 joules. So what is your delta B? 2 into 0.02 divided by force P. The force P is 1000 newtons. So you see this is 4 into 10 power minus 4 meters. So that is deflection of point B. Any doubts? Anybody has any doubts?
सर ये फोर्सेस वो वर्क डन है एंड देन वो टोटल स्ट्रेन एनर्जी है
So
दोनों
whatever is the work done by external force, that gets stored as strain energy. This is law of conservation of energy, you can say.
ओके सर
So now you see one more thing. So we found the deflection of this point using energy principle, but we can also find it directly. How? You see this bar is contracting. So after contraction, this will come like this. Right? This bar is also contracting. So after contraction, this bar will be like this. Then there is one more thing. This is also stretching. This bar is stretching. So it should become like this. Can you see this?
यस सर
So how to reconcile it? Basically, these two things will not lose any continuity.
सर एंगल चेंज हो जाएंगे सर सबके
Yeah,
बीच
angle will change. There will be rotation of the bar. So how can they have the same position? Because of rotation. So this is here, this is here. Let's draw it again. It's the time is running out. So this comes here, this comes here, this goes here, this goes here. So if you say there is a rotation like this, so body will just rotate. It will have a rigid rotation instead of any twisting, and it will maintain the continuity. The standard example for this used to be like this. Suppose we do like this. These are the two bars. Now this distance is fixed. Now this bar, suppose
तो जो आपने सर ये दोनों डिफॉर्मेशन बनाई है इसमें एक पॉइंट तो सर हिंज पॉइंट है तो सर वो तो सेम रहेगा लाइक
this
वो
point.
से
Just
आगे
listen to me. Listen to me. Actually, time is running out. So this will go like this. Suppose there is a tension. This goes like this. So how can the 2 points be same? So this bar will rotate like this. This bar will rotate like this. So you will get final configuration like this. If there was a tensile force, you get my point. This distance is not changing. So you will be able to find this displacement because you know this stretch. You know the displacement. This fellow goes like this fellow goes like this. Now how they can maintain same point? If this bar rotates like this bar rotates like this. So this distance you already know by stretching, how much it has stretched. Only thing is you have to find this distance. So this is simple trigonometry. So you try to check out whether you can get the same answer. Okay. So the class is over.
Sir, can you please post the recording of the last lecture as well?
Yeah, I will try. Okay.
Okay, sir.